Next is problem number 3. So we have a manufacturing process with an annual demand, and then production averages 100 units per day. So that is your production capacity. So this is a production order quantity problem. So this is going to tell us that this is not an EOQ, but this is a POQ, production order quantity. So holding cost is given, setup cost is given, and we want to know what is the batch size. If they wish to produce this product in economic batches, what size batch should be used? So number 3, okay, now given annual demand is 10,000. Okay. Now holding cost is $50 per unit per year, and setup cost is $200. Okay. And also given is production order quantity, or production rate is 100 per day. Okay. And demand rate is also given as 40 per day. Okay. So what is the production order quantity? So the formula is 1 minus D over P. So this is the formula that we have to use. So 2 times 10,000 times 200 divided by H is $50 times 1 minus 40 over 100. So this is 2108.19, or we'll round it to 2108. So that's our production order quantity. So the economic production order quantity is 2108. Okay, so we are done with this. So what is the next question is, what is the length of time in days to produce one lot? So let's call this A, and then it is time to produce one lot in days. So you're producing Q, and you're producing Q at the rate of P per day, and that will give us the answer. So 2108, okay, divided by 100. So that will give you 21.08 days. Again, this is on the average, so you don't have to round it. Then the next question is, what is the maximum inventory level? So maximum inventory level, which is I sub max, is given by Q over P. So that is the number of days it's going to take to produce one lot, and during that time inventory will rise at the rate of P minus D. So this will give us the maximum inventory level. So that is 2108 divided by 100, and then 100 minus 40. So this will give us 1264.8. So that is the maximum level of inventory that we will reach. The next question is, what is the time between orders in days? So time between orders in days is given by Q is the batch size, and how long will it take to consume all of that Q. So it will be Q over D, and that is equal to 2108 divided by our demand rate is 40 per day. So this will give us the, on the average, how many days will one batch last. Okay, so what is the time between orders? We've done that. How many order cycles are there per year? So the number of times you have to place orders. So number of order cycles or number of orders per year is you take the annual demand and you're going to order Q at a time. So that will tell us how many times we have to order in 1 year. So that will be 10,000 is the annual demand, and we're going to order at the rate of 2108 every time, and that will give us the number of orders we have to place. So that will be 4.74 orders per year on the average. And then finally we need the total cost, annual total cost. So here that would be annual total cost is given by the annual ordering cost. So annual ordering cost is number of orders times X. This is exactly same as in the case of economic order quantity. But annual holding cost here will be the average inventory is not Q over 2, but I sub max over 2 times H. So this will give you 10,000 over 21.08, like that. That's our number of orders, okay, times the ordering cost of 200, okay, plus I sub max, the maximum inventory level is 1264.8 divided by 2. Okay, it's not Q over 2. You must carefully look for that, times $50. So that is equal to 948 for annual setup cost and 948.60. Okay, and because we rounded here, that's the reason why it is not exactly the same, but it's almost the same. So that will give us 1896.60. So that's our total annual cost.